Punch. Nothing to see here. No, nothing going on. Actually, no, that was a little skit because we were watching Jumanji: The Next Level. I get recently, and I was amazed when they have people who are faking playing games and trying to play Street Fighter. Like, this is what I'm doing. It's like, no, that's not the wrong combination. That's never going to work. Or you see hackers in like Jurassic Park. And this is a lick system. And it makes them laugh. But anyway, we're back another university of the week. We'll see how the curse is going to go. And just one episode this week after a lovely little foobar fun time. Granted, it all worked out well because it was both GUM, it's both UI. You just got all the UI done in the same time. Not necessarily the same order, but it worked. And we got all the content set up. We got the pipeline bits updated and all things ready. We had things prepped. And then we went and installed GUM and got it installed. Although, mental note, I still have to go and edit last week's to straighten that out. And, well, not straighten the video out, but set the time code up for a little explanation of what would happen and fun for anyone who's watching it afterwards and then missed all the live fun. Thanks for Victor jumping onto the chat and then pointing out to me, yes. Don's telling me he's edited something in lead, and I've no idea what he's done, but we shall see. As ever. Right, let's get on, as it were. So we're here to talk university. We're here to talk 2D games. We're building out the 2D tutorial with our lovely slime game, and we're going to do some lovely slime mechanics this week. As usual, we're quick overview of MonoGame, quick jump into the course, a few what sessions we got. As we keep repeatedly say, it's like you can find us MonoGame out on the tubes or the Twitches or Facebooks when it's connected. It's not today because, yeah, it does funky stuff. But yeah, we're doing the 2D tutorial series. I'm going to try and maybe start up probably next month another course going at the same time. We'll likely do the 2D shade course, getting it live as we get 385 out and everything else, and get 3D platformer ready and all that such fun. Catch Tommy's stream again tomorrow. He's doing more. I think he's going to take a break from doing online book fixes, although I enjoy that, seeing how his mind works and resolves issues and the complexities we deal with in MonoGame of trying to get all the different code streams from all the different platforms all working in sync and in the way they're supposed to be working. I don't know. And yeah, I'm just double checking we got audio because it's more fun. And Doma is talking about. Oh, we'll come back to that. Dom is also talking about Spotlight and getting out, and he's got another show just ready to go. He's just getting everything done, where we showcase all the best about MonoGame and so on and so forth. But anyway, yeah, it's broke my screen share again. Let's try this again. There. I noted that one. I think it missed from my input, but then it just disappeared. And we'll switch around now. Now it shouldn't be. Now if we're on here, so we can go to NuGet. And we can go here. Go to MonoGame, yes. And okay, we'll pick up one of the frameworks. And this is at, well, that's the preview package, but the public release is 3.8.4.1. Thank you, NuGet. Where's versions? There we go. So the current live version is 3.8.4.1. So if you're seeing something different, then let me know. The tutorial is all based around the 3.8.4 series. That's the stable public release. The 3.8.5 release, which now is in its third preview. I want to get another preview without that. Probably not this week, maybe this weekend. We'll need to finish need to quickly patch the templates. As Tom's got most of the essential fixes, he's mostly working on unit tests. Let's get the latest get another preview out, ready for the full 3.8.5 release. Now, no, 3.8.5, while it has a load of fixes, Mac users, you'll love it. It fixes the MGSP editor launching a Mac. There was a critical bug that seemed to sneak in there at some point. And I'm looking at this now. Look at this. Nearly 80,000 from 3.8.4.1. Go MonoGamers. It's not the largest. Nothing. Let's see how far back. How far are we going? Yeah. So 3.8.1 So with 300,000 downloads, to be fair, I think a few thousand of those were me. And the previous release was nearly 700,000. Come on, MonoGamers, get out there, get downloading. We can do better than that. Get more games. There's lots of public releases going things out. So yeah, I want to get another preview out, and then we'll do the full 3.5 release. Tons of bug fixes, mostly for Mac users. Quite a lot of the extensions and things have all contributed to the community. But the big highlight for 3.5 is the preview features. So there's a new Vulkan graphics platform. There's a new DirectX 12 platform, which people on the open hours have been testing like mad already, and it's mostly working. So if you want to do Vulkan and do DirectX 12, it's there. But also the big news is new content build, and I'm going to hope I will definitely get some more content out for that, as well as the documentation, which I got reminded is out of date already. But things are moving fast. If you don't stop and take it, you get the picture. But anyway, we're here to start MonoGame, and MonoGame is a C# game development framework. It's probably one of the easiest ways to get into game development. Although it's very code heavy, it's code first. There's no flashy editors. There's no tools that you've not generated. But that's also one of the powers, is because you don't have an editor to learn and different ways to things. You just need to know how to program games. You also understand the game programming loop and how things work and render. And quite a few universities are taking this as a good introduction to C# and learning programming. And good luck to hear it, Michael. Again, any issues, any things that are creaking? I think Chris Aristotle, who's jumped on the thing, we still need a little overlay to announce that the author of the tutorial has joined the stream. It's good recognition. But yeah, the content builder is a massive improvement. It changes one of the fundamental things that I loathe and we've grown to hate in the MonoGame content editor. While yes, it's a nice little graphical tool, you can see lots of tests and things, it gets in the way of building games. And also, 9 times out of 10, if you've got an issue in getting started on MonoGame, it's the content builder's fault, because it doesn't load, because it's a .NET tool. And yeah, anyway, so getting started, going through the whole 2D tutorial, and it's simple as that. 2 clicks, you're in, done, we're started, and then you're building it out. Let's hide that now and get it out of the way. And for this week, since last week we did 2 chapters. If you didn't see it, go and have fun and hilarity at my realization halfway through the customizing after you've implemented it to realize we hadn't actually implemented it. But you got an extra 2-hour-long session out of that. But today we're talking about more of the nitty-gritty. So we've learned, through the things, we learned how to get content into the project. We worked with the content pipeline. We've worked out how to get textures from our asset pipeline and render them on screen, and different ways you can do it. We then did about, compartmentalize on making it a drawable element for things we're going to draw, how to animate it, working with input, looking at things like 2D collision detection. It's just 2D. When you get to 3D, the extra third dimension really does sort of mess with your brain. And we looked about doing some tile maps and things, some audio, which is good fun, the fun world of the out-of-box sprite fonts, then a lot of other little setup features, more to do textures, and then we got a very basic UI placed in, but using GUM to make it pretty. Although my general rule is first make it work. Doesn't really matter how it looks, and then make it pretty. Because invariably, and the reason I say this is simply because your UI will change as you're building the game. I usually do this case study for XR or VR projects, because you can't tell someone how something will look in XR or VR. You can only put a headset on their head, and the second you do, they go, "Oh, I understand now. I don't like that. Can you move it here?" It's true also in games, because you'll find that you'll do this whole design. It looks great on paper. You put it on screen, things move around, and something like, well, no, that doesn't make sense over there. I need to move it over here, or I need to change the style. And if you've done all the artwork in advance based upon some piece of paper design, you then got to spend all that money again to get it redesigned. Or if you're one of the really talented folks out there who can do their own, kudos to you guys. We hate you. We secretly hate you. Those who can do absolutely everything, we secretly hate you. I can't art. I can barely 3D model, but I can do funky things on screen. But anyway, so once you've got your game, we then just not think about, fine, we've had this idea of this game. What does it do? And for Dunya Slime, the premise we got off is a simple snake game. And in this case, now we're walking through what we've got here, and we've got some basic principles for how the gameplay is going to run. So we're going to move the snake in 1 of 4 directions. I can go left, right, up, down. Although going in the direction you're going is really just you're still going, so it doesn't do anything. You can't go backwards, so you can't eat yourself. Sounds fun. The snake is not limber enough to eat itself. If you try to go back, you can't. You're still going forward. So you can technically the only direction you can go is perpendicular. So you can go left or right, and then that will change your direction whichever way you're going. If you try to eat yourself, game over, man. Just game over. Game over. If you then go and eat some food, which in this case is a bat, you're going to grow. And you'll get longer, like the old Tron light cycles. You know, the line will continue to grow. And if you hit the wall, if you hit yourself, if you do something funky, you're just going to die. It's all better. But the reason we chose this is it's fairly simple mechanics. And it covers all the different elements that we need to when we're doing a basic game, rather than just trying to draw something. Actually make it think. Do design, do it, understand how it works, set rules for how your gameplay is going to run. It's not like when you're prototyping, you think, I'll just try to throw it in this, I've done this. Oh, what if I throw a grenade in? Well, the grenade look nice, I'm going to explode. And then you spent 3 weeks going down those rabbit hole of, oh, look, this thing looks really cool. But what about the game? Oh, yeah, I've got to build a game and do stuff. But it happens. So in these controls and based on the mechanics, we prototype, we test things out. We know that we can turn left, we can turn right. Going forward does nothing, going backward does nothing. But obviously that depends on the direction we're traveling. So we look at what we're doing, we got the different things, and knowing the case of this is the direction I'm going to go, more segments going to come up behind me, keep it simple. In that directional segment itself, we're going to be checking every frame. So have you pressed something to do something? And then based upon that, we check the rules. Have you pressed something that means we can do something? Can we go in a different direction? Is it just, I'm going that way anyway, going back, stop? And just analyzing how it's going to work. And this is when we can get funky things. So while you're saying like, hi, I've got this texture and I'm moving on the screen, segment by segment, or just moving along. And what we're effectively going to do is when we're actually going to grow, we're going to take our first segment and actually what in reality we're doing is we just simply don't move it. So when I grow, I'm moving the head along as I do, but I'm simply just leaving the last one there, but then that one moves along with me. So you can do funky things. And to help control this, in case we do things basically like pooling, where we know we're going to have a certain segments and we've always got several in line that we're going to draw. And here you can see the case of we're copying the head to draw the body out and updating the flow as we do. And then effectively when we're growing, we're just adding more into that loop. And then it's case of the same logic that's moving along, doing what we're doing, simply adding more, and then that follows the same path. One good cardinal rule, especially doing game development, is don't make things difficult for yourself. If you start finding you down another rabbit hole of, there's lots of complex logic and you've got to try and do this, stop. Pays to stop, sit back, think about it. Could this be done simpler? By and far, that is one of the best rules, because I know I'm guilty of this myself. In some projects, I go through, okay, I do this and then you realize halfway down the line, well, that is exactly the same code and the same thing. So maybe I should simplify and just do it in one place. So as we're growing, we're just adding an extra segment on and then leaving it to move around. And also, as part of that movement, we can use the same technique as well as we're moving. So as to limit what's drawing, so we can reduce the kind of overdraw on the screen, we know that if you're a 4-piece segment, I can draw it here and it can stay still. until eventually the tail catches up, then it's gone. So that means we're only drawing the elements that are actually moving on the screen. So we're simply adding a head, removing tail, adding a head, removing tail. It turns, the head gets added down here, gets removed from here. And it keeps the same flow and logic. So while, yes, we could keep moving things around, we can keep it simple. Don't draw things you don't need to do, and so on. And then, when we're growing, all we're simply doing is we're almost saying leave the tail section on for one more frame. So even though it looks like you're growing, all we're really doing is case of we're saying moving along, but instead of just removing the tail as you add a head, you just leave the tail for another frame and then move over. And then we got like a game over challenge. Or basically, all we're really going to do is just pause the screen and say game over. Not really do anything funky. And then when we start a new game, we clear the board, put it down, keeping things simple. Yeah, this is one of those things. So Chris and his creative wisdom thought a snake was too much fun, so we went with slime. Hence, Dungeon Slime was born. And the slime that got all animated things is moving on. So one thing I do like is, unlike a worm or a snake as it's going along, which is just a thing drawing along, always something got as like an animated, and it's good because it adds a bit of punchiness to the actual character itself. It's actually going on the screen and nicely animating as it's being there, so it's a bit more fun to look at, and we liked that when we put it forward. So we're keeping kind of the animation frame being in, so each of the segments of the thing is pulsing until it drops, moved around, and so we can control this, and all we need to worry about is the case of which direction has been placed, which direction has been pushed, sorry. Is this perpendicular? Great, I'm doing something. If it's forward, ignore it. If it's back, do it. And go to sleep and wake up in the morning. Go on, we'll take a break. Because we're lots of talking in this. Dungeon Slime is basically Snake is one of the most simple games you can get away with, and for a beginner, that's good. Can I find it? I might not be able to find it. I'll show you my secret stash here. So, for instance, the 2D game uses a snake get slime game because it's limited input. It's got good basic mechanics. Thing you can work through. It's good as an example project to build on. The things like the 2D platformer, there's too much in there. You've got to add all the different mechanics. You've got break or block, you've got jumping, you've got passing blocks, you've got enemy enemies with their own animations of moving around. It's too much. We've also got things like Ascent or the ship game, and that goes all these complicated 3D things. So for beginners, we decided to scale things back and to keep the premise as simple as possible. You're there to learn how to program, learn how to do all the things with assets and get them on the screen, then to build some gameplay, have some menus, enough so you've actually got a game you can then build upon and work forward. So for Funky, can I find this? Now, this is the challenge. I'm not going to find this in time. Hold on, have I got it? No. Darn it. No, I'm not going to find it. I shall look it up next time. So the 3D beginner tutorial as well is the same kind of idea where we've got a simple 3D shooter. You've got like a Star Fox style game where you're flying forward. So we're keeping the camera elements fixed so we can actually control it. We've got all the different elements for doing things. We've got projection into 3D and 3D characters coming through 3D space and things like that. Again, putting things forward. And yeah, Chris has put a nice little example here. So, I say the whole point with the slime or the snake game is getting things in. The game itself is not really important, but you're trying to teach the mechanics and understand the principles about how to build a game. From then, you have a good understanding to go further and do more. When I wrote a book for Unity, don't tell anyone. In that, we chose a very simple sort of RPG kind of mechanic where you had a character coming on the screen, they chatted to other people, They could go out into the open world, travel, so keeping things simple, and then a very simple battle mechanic. Well, the book's this big, so you can go overboard if you want to, but we try to keep things simple. But anyway, I digress. Thank you for the question, Data Guy. Data Cool Guy. Okay, so in this now, so the input we've got in the game so far is mainly around menus. So, have I click this, have I get this, going to let this, and we can move left and right. But we want to try and make this more into a control style logic. So this allows us on top of so we use the back end input for doing the controls, and then we add a controller then to actually do the logic. So knowing what's been pressed when, can I do this, can I not, what does it do? So it looks like we're going to jump into the code. So let's go and do that. Now I need to review some of this. As those who know have been watching us for weeks, is that I have a tendency to take Chris's tutorial and then do things differently, just because that's me. So here we are on the project. We're using VS Code. You can use Visual Studio if you want. There's really no difference. It's just a different interface, same camera capabilities. And we have, let's see. In fact, this worked well last week. Let's see if we can do this. Let's put you over here. There, and bring the tutorial. Ooh, over there. No, that's not the tutorial. That's my folder. Get it together, Simon. Here we go. And oh darn it! Wait, no. Let's make this full screen. We've got this AI stuff in here. Why is that on by default? Is it? No, it's not on. Oh, but we did forget. Go to sleep. If you're going to type in code, I don't want this thing getting in the way. Right, let's try that again. Over here. Done. Okay, all right, that's fine. We've got no space. So, as it's talking about here, in our library, in our input, we've got our input manager. And this has got all the things we have at the moment for controlling interaction inputs. We can so we got like move up, down, left, right, and let's see. We're going to create a new game controller class. Do it again. The simplest. Do we need to do this? The only thing that's new is action. I think we've already done this. So through the course of the tutorial talks about setting what we've already got now, which is the input manager. But how is this different, he says, to, I've gone through this so many times. Input manager, we set up, we've got an input class. We'll do that. Now the input things. I'm sure we created an input manager. Gamepad info. Yes, we set up an input manager, and it's got all the right. Okay, so yes, this is where we diverged, as it were. So in the original implementation, in case of, we set up a class which just handled input, and all it was doing, it was managing all the different input states and things like that. So the input manager was just getting state, and then it was here in the game. We were doing well. If input does this, we do this, but we diverge, we change. So we've actually already done this. So in here, we've already implemented in our input manager, where it's getting all the states, it's doing all the updates, but we already moved through the magic of development and refactoring. We already did. So we've actually already done this. So yes, we've already got move left and right. Okay, so. Well, let's see. Chris has added some extra different ways. So yes. So right. If I look at move right. So today with move right, we're getting D or keyboard right. Yeah, we got that. We've got D-pad right, but he's also got a thumbstick, and also it does look a bit cleaner. So let's clean this up. There we go. Gamepad, and also Chris is adding in an additional one, which is gamepad. Oh, but we're also using more button press now. Have I got that? Did I implement that? Yes, we did. Or did I? Ooh, did I? Did I? Keyboard. It's in the keyboard. Actually, it's in the keyboard class. And is there one in the gamepad class? He says, because we created a gamepad info. And do we have a button up, down? Yes, we do. Right, good. We're not missing anything. But obviously, my original transfer implementation is just doing that. Is it down? But here we're saying move right. We need to do was just press. So right, let's make these like the tutorial. So was key just pressed? Was button just pressed? And we want to copy that. And let's go and fix these. So D-pad right, we've got thumbstick. Chris, you added more controls than I did. There we go. Left thumbstick, right. And as we can, the key classes and button classes, that's something from MonoGame. Data, I'll come to you back to you in a minute. Those are MonoGame, and then these are functions where all this is really doing is saying, has this button been pressed in this frame, and was it not pressed in a previous frame? So that can only happen once. So in the previous update, the button was not pressed. In this update, it is. And that just means if I press it and hold it, nothing happens because I have to keep pressing it. It also means can't keep moving around. Where, yes, previously in the demonstration in the system, when we're taking the texture, draw it into the screen and moving around, we wanted to be able to hold the key and keep it moving. But now we're limiting the inputs. We do need to go around and fix this. So let's move right. And we need to do the same to the rest. So okay, there, and okay, we're using, let's see, now this is move left, using the thumbstick left. Okay, we also need to use these. So let's go quickly change these around. Because now, as I say, we're no longer pressing and holding and moving our slime around the screen because we want to add some element of gameplay control into it. Okay, so I'm going to move down, see, increase speed, fine. And move up, we want to do the same. Okay. Ooh. Yeah. Here we are, just random meshing code. I'm just making things look right. So move right, move up, move down, it's going to be the same. Nearly there. There we go. It is just my preference, really. Is that if I'm having input, I want it all in one place, and one manager, one controller, one script that's actually controlling it all, which is both reading the input and then telling me the actions that need to happen in my game: move up, move down, move left, and right. Then in your game code, you can use those kind of concepts of, right, has this happened? Has this happened? Has this happened? And if you want to then remap the controls, I only need to do remapping in one place, not throughout my game, which is a lifesaver. Right, so up, down, left, right, pause. Oh, we're also using that for pause as well. Yeah, we're already doing that. And action, now that seems to be a new one now. Enter at A. Are we using that for anything else? Oh, wait, no, we are using A for that. Is that? Oh, gamepad A. Right, sorry. Gamepad A. So are we using enter for anything else? Let's have a look. Keys dot enter. Whoops. Enter. No, we're not using that. So right. So we now need this action command option. What's after that? So okay. Pause. Well, we're not keyboard and gamepads, we're doing gamepad. Oh, it's starting. Gamepad, and we are core input keyboard. And gamepad 1. Okay, now we're doing enter and A. Thank you, Chris, and welcome on the journey. I know in the many decades ago when I started learning, enjoyed the C# is a fantastic language to learn game development, and it's a good entry level because it's all of the power but none of the worry. When I started, I had to do C++ and assembly, and in there, if something went wrong or something went and didn't work quite right, everything just exploded, and you had to think about all bits and shifts and lots of memory management stuff. And it was several months into my lovely experience of trying to learn. And then along came a framework called MDX, which was the very, very first C# game programming framework. And then just a couple of short months after, XNA, which was a breath of fresh air because it was a whole framework, not just bits and pieces for building games. And thanks to XNA, MonoGame is now here. So welcome on your journey. I'm glad you're here and hope the shows help. And if you have any questions, even if it's not just about this week, if you want to ask about common things, ask away. We can get to at the end of the show and we'll get on. So here we are. Right, now we've got our generic input manager. We're not going to call it game controller. So we'll have to do some change. So we'll do some changes and differences. So in here, case of like, it's all the same principles here. It's a case of, or I don't need to worry about cross-platform. So if I add another platform and it has a completely different style of input, I've got this one class to change, not my game. My game is the same because we're building around the simple game mechanics. You know, I'm moving left, right, up, down. I maybe have enter or open for controls for other menus and things like that. But those are the behaviors of my game. What makes those things happen shouldn't be in the game. It should be outside somewhere else. And then if I want to add keyboard remapping so that, and I don't like WASD, I actually like to use IJKL because I'm right-handed. I'm not, I'm left-handed. I know these things, there's only one place I need to do it, not the entire game. As ever, when building games, cardinal rule is the KISS principle, keep it simple. And if you find yourself drifting off and doing something and thinking, maybe I'm going too far, stop, sit back, relax, look at it again. In some cases, I did a project for the competition called Dream Build Play, which was another thing XNA did brilliant. I would love to do something like with MonoGame, but we'd have to get serious funding and help. Yes, we are still talking about doing a game jam. We also have some very serious ideas of prizes and things we've got lined up for that. So stay tuned. You didn't hear it here. I shall deny all knowledge. But in Dream Build Play, I was building a project called Hack, where we're effectively a simple thing of you're creating lines on a circuit board. And I went down a horrible logic of trying to have a whole texture I could draw in it and do lines and things, and nothing matched up. And then the screen resides and the mapping didn't work. And in the end, I abandoned that and started again, and then just basically did simple paths. Draw a path. If the path was within a certain range, they connected a line, and you could draw circuits and short circuit and hack your way into a system. Don't be afraid to throw away code. It might sound harsh, but it's a case of you will learn more from your broken embers of things that you've done wrong than you will do just copying and pasting a tutorial which tells you how to do it one way. In fact, one of the things, and Chris and I talked about this when this tutorial was being built, is that I prefer concepts or tutorials that teach you. You shouldn't be it's the whole premise of, you know, if you give a man a fish, he will eat for a day. If you teach him to fish, then he can feed his family and get his son in the business, and then start a whole shipping business and start collecting shrimp and selling a whole shrimp boat system. Going Forrest Gump now. But anyway, back to the game. So we've sorted out our input now. We've got our input working. And so we now need to think about the actual gameplay elements. Now, we have already got our slime drawing on the screen, but it isn't really a thing. It's just a sprite, a texture that we're drawing. We're doing animation. It's not an actual game component. So one of the things that's really critical when you're looking at how you're doing is that you don't want to be thinking about drawing art to a screen. That's a sort of byproduct, a secondary thing that's on the end of what you're going to do. That's the result. When you're trying to build it out, you're trying to think, well, what is this thing it's going to do? Building the mechanic around what it is, and then the rendering is just a byproduct of that aside. That's something that happens because if I put this concept in the screen, in this place, I'm going to render something, or I might do something. It might be an effect of something else on here, but the core concept itself is static. And then here, this is what we have here is we have a segment of slime, a slime segment that can then form a chain, which is a chain of segments. And then on of those, I'm going to draw these things in this way. On, off, and good. So we start off by creating a slime segment. Now let's see where we're doing this. We're creating a new folder, guys and girls. Here we are, your main game project. So here we got one of the things as well. If you watch back in previous weeks, we've tried some degree of separation. So we've got the game code and we've got library code. The library code is meant to be like engine code. We can share. What you might find in some of the other samples and tutorials that we go that a bit further. So you've got the actual game code itself is in a library, and then you've got your engine code in another library. And the aim is that you want as little as much as possible. Hey, John, welcome back to the show. In your actual runtime project. But the moment for this, because we're learning, it's beginning, we're just keeping things simple. Yes, we've got the idea of abstraction. We've got our engine code, and then we've got code related to our game. But then if I want to take that to another platform, say I want to do DirectX instead of desktop.jl, which is what we're starting with, then I'd have to copy or reference that code. And there are ways of doing it. You're never stuck down the loop of doing things. Moving things around is simple, so don't worry about it too much. But anyway, here we've got scenes where we set up our game scenes last week, and then did some UI. So we want to create a new folder called Game Objects. Yeah. Before Unity coined the term, Game Objects was a nice, reasonable expectation for how you describe an object in your game. Unreal doesn't you get? Unreal uses entities. I'm not sure what Godot uses. I think Godot's artifacts. But in this case of a tutorial, a MonoGame doesn't have anything, so you can call it whatever you like. Objects do art. I'm butchering something there, probably. Anyway, we've got a slime segment, which is going to be one of our components or game objects in our game. And we're going to start off and get some code in here. So, right. We look at this, and we're simply saying, right, a slime segment is something in my game. It's got a current position where it's at. We've got a direction where it's going to. So this is this is where it will be. That's determined by the current direction that the segment's going. So as each segment it knows, I'm going to go this way, I'm going to go that way, or down. And also critically, what its reverse direction is, which case of you cannot go this way, which is ultimately it's just the inverse direction of the direction you're going. So I've got my direction, I'm going this way. The reverse direction is the opposite way. And it's a simple vector 2 says, right, can't go backwards, but there we go. We've got squiggles. I hate that. No, it doesn't need to be read-only. It doesn't have to be. Yes, it's a read-only getter. That's enough. I don't need to make it read-only as well. There's me arguing with the C# compiler. So there we go, some explains. Yes, as well. We're creating this as a struct. Now, this is one of those little programming little gotchas. Sometimes usually misconstrued about how they work and what you're going to do. So you have structs and classes. A class is a full-fledged object, and that lives on the stack, arguably, depending on the type of data it's in. It's active runtime data. It has operations. It does things. But a struct is an object which lives on the heap. Now, the main difference is how you manage memory in your game. You want to put as much on the heap as possible because heap is like almost, I would say, free memory. It's more performant in the way it works. because it also compiles better and it breaks down, it makes things easier. But where it stands is, oh, well, just make everything a struct. Structs are, because they live in a specific type of memory, there are limitations. One is they can only use value types. Is it value types or reference types? Does Chris say? Yeah, I think it is. That use value types, which basically means they are a simple construct in memory of like basically it boils down to, is it an integer? Is it a float? Is it a string? Basic types. You can't have another class in a struct. If you do, you get into a situation which you infer what's called boxing, where the compilers constantly have then convert what you said is a struct, but it's not. It's a container with classes into a class and then back again, and it's not good. Structs can only contain value types, so the very basic most types. So a vector is okay because a vector is also a struct made up of several float values. So you can have other types which are based upon value types and still be okay. But if you start to try to put anything into a struct, you're creating problems. Understanding memory architecture and how you're defining classes is very important. And structs are one of the most performant ways to store data in your system, especially if there's a lot of it and you need high performance. However, follow the rules. If you try to use something that a struct can't support, you might as well create a class because you create more problems for yourself. Structs have all of the limitations. Like, well, today in C# 9.10, you can't have constructors on this, so you can't initialize things, you can't initialize properties or default values. You can have things, but although that is changing as languages evolve, you can there are more things you can do. But Chris has a good point here. It's like, learn about data types, working. Actually, Chris, I might suggest we make a reference change to this, because I look at this again in fresh eyes. Structs don't work best with value types. Structs can only reliably work with value types if you put in fact, you state it as a case of if you put in reference types with like classes, so sort of compound classes and other functionalities in there. If you have textures in there, for instance, it will cause boxing that negate the performance gains you'll get to a struct, and also can create you more problems later on when you're trying to diagnose why it's not working. Anyway, this I recommend reading up on, especially if you're new to C#. Understand about how C# handles the memory based upon the types of data you're going to store. If in doubt, use a class. You're not going to lose anything by using a class definition, but structs are there good for like really high performance element memories. Granted, this game we're doing. Oops. With Slime, we're not really heavily performance, but I always find it's the best to use first principles to get it right first time and learn from the start. Okay, so we got some structure which describes where a segment is and where it's going. So then obviously within that, we then need to change we've got to define or work on what our slime is, because a slime is one or more segments. So, yeah, slime segments. So we're going to create a slime. And you see here now, slime is a class because we're going to have all the data in there which is not value types. And okay, so I'm just going to create another game object. Game object, create a new file. I could have just used the icon up here, but I get funky at times. Let's copy that in. I'll start building out slime. So good old slime, our hero of the day, is going to go around and devour all these bats in the system. Yeah, fun fact. So I remember someone wrote a slime game that was, it's about a character who I think it's called On and Off Again, where you're a character inside a computer system and you're there to purge the virus. I love playing that game. He also did some really nice particle effects and doing things. Yeah, we'll put it into game objects because it's an object in the game. Again, how you organize your code is also another thing, because if you then need to figure out, well, there's an object in my game, right? Well, it's in the game object folder, I know where to go and find it. You can always search, but searching sometimes breaks what you're trying to do. Yes, we are going to have this. No, we are going to add things. Things are going to break until we get to the end. But hold fire. If you're doing it for yourself and you're walking through, you are going to find lots of red squiggles sometimes as you put this code in. But it will all make sense at the end. So we're going to start off having some fields in here. Okay, yes, Chris. Garbage collection. So we're told about heap and the stack and how memory works. What the garbage collector effectively is a background operation in C#. This is how it handles memory. In C++, you have to do this yourself and can get into trouble. But in C# it provides this nice little facility in the back end which does it for you. It is both a boon and a curse. What it effectively does is that it's constantly running through the code that you're running and looks at what is looking at another bit of code. And if you suddenly set something to null, or if you stop using something, the garbage collector goes, oh, look, that bit's not used anymore. I'll clear it out of memory and free up some space so we can do something. So we're not constantly filling up our memory. We're building it up and coming it down, and it's cleaning it out. Now, in a game like this, you don't need to worry about it because the performance impact of it is minimal. You think about a much larger game. You're talking about a game that's using gigs of memory. And as you say, you change scene. And so you stop using a load of stuff and you're going to start using things. Now, if you don't manage this, it will. And it will go on and goes, oh, you're not using all that stuff? Right. Hold on to your game for a second. I'm going to go and clean up house and start sweeping the road. And it will keep doing that until it's finished. You have no control over it. So what larger projects do especially is that we change the time that we're going to that happens, and we can force the garbage collector to say, right, I'm doing something now which is of something else. Can you go and clean up what's not being used and clean up the memory, while I can then continue on, and you can then break it down into smaller chunks. If you leave it just to the garbage collector, I think it's every 600 frames or so. It's some deterministic time where it goes, right, hold on, I'm going to clean house. And if there's a lot to clean up, your game will freeze and your frame rate will plummet while it goes off and does what it does. So it's better on larger projects to then think ahead. Right, I know I'm not going to need those in the future, so can you clean up what I'm not using now? And then when I get to that next bit, you've got less to clean, so you can break it up into smaller chunks of what it's cleaning out from the memory, and refreshing everything else and doing it in advance. Or if you're using the content manager and you worry about assets and textures that are loaded into memory, don't worry. The content manager will also help you out. But again, think about how much you're going to clear out at once. Don't do everything. Don't do large sections. Do it in little bits. But again, this comes a concern only when you're reaching a point where garbage collection starts to take an impact, and you will notice in your game, and you're doing performance checking on what's doing. So what the rule of thumb, and the way we break it out from the beginning, is plan ahead. If you know you're going to have a lot of stuff to change way down the line, then break it up over several frames rather than just waiting for the garbage collector to come and let it do it all at once. So you're going to come up to a loading screen, right? Okay, these are there. Garbage collector run now while I'm doing this little transition. So I know the whole thing is clean out, and then I'm going to come up and I'm going to load a load of stuff at the same time and manage it. It takes practice, it takes learning. There's no real tools to tell you which way to do it because every single case I've come across is different. But it's a learning experience, and we go through. Right, back to the show. But yeah, go ahead, ask. It's lots of fun. But also read up about the stack and the heap, because it's the stack that's cleared out predominantly. The heap works slightly differently. It's still cleaned up, but it works differently. Or it's more efficient because it can overwrite memory better. Anyway, right. So in our slime, we have a lot more properties and things we need to worry about because, we need to know when it's moving. We need to know when it can move next, because obviously it's moving along a direction. It's always moving until you turn. So we want the time that happens between you pressing something to mean something. We also know next direction, which is determined by your input, and saying, right, go this way. Yeah, how fast is your slime going? How much is it jumping forward? How many segments it's got, and the animation that we're going to use for our slime segment, which is the same for each of them, except later on. And you can read what these do. So with our slime, we know what's on the screen, we know what's going to do. We also want to have some events. Now, effectively, an event is simply a case of, right, this happened. And the beauty of that is that you're decoupling from what the thing is that's going to happen to the reaction that happens. And this means that I don't need to have lots of references working out all that, but this thing needs to look over here and this things. An event is a way of just decoupling that to say, right, here is a bucket. If you want to know when that happens, you go and listen to it. It's called an event subscriber. So you can subscribe to it and say, right, if you want to know when this happens, you go and listen to it. And then when it happens, I'll tell you, and then it off. It's completely broken apart from the case of you could have one thing that happens, or you could have many things that happens. We usually do this for things like UI. So if the health changes, use an event rather than trying to look up to all the UI elements and know I've got to change this, this, and this. No. The character has taken a hit, it's taken this much damage. Right, here's an event, I've taken this much damage. The UI will change, some other logic will change, everything else will change, but the code that tells you that something's changed doesn't need to actually know what's going on. It just knows, by the way, I've lost this much health. And we're doing this for collision. So if we detect that our slime has collided with something, either its body or the wall, we're simply going to go, I've hit something! And then something else can worry about, oh, you hit something, right, well, that's game over then. So we're going to have our event. Oh, let's format this to make it prettier. So there's no event. So that means, like I say, someone it can shout to say, I've collided, and something else goes, oh, well, I know something to do with that. Okay, then we're now a constructor. So obviously the only thing we need when building our slime is to know what it looks like. So we're going to set our sprite, which isn't critically. Oh, go away! No, go, stop, go away. Which is an anime sprite, which is the concept we built earlier. So we know this. It's a texture. It has an animation which runs at a frame rate. And off it goes. Although that's the only thing our slime needs to know when it gets built and put onto the screen, because we know here's our concept. Oh, crying out loud! What did I press? What did I press? Go away! Discard. I must have done like a blooming Copilot review or some stuff. Anyway, we've got a concept of this our slime. This is how it's going to move and what it's going to do. And so for that, we also need to know what it's going to look like. But it's the only thing we need to know. If I've got independent sounds, I might also pass some sounds to it. Nothing fancy. Water. I just have, on stream I have water. I do have a box of Monster Energy. I think I finished all that. But see, more fun than these things. If you've seen this is our lovely MonoGame logo. See, I'm going to jump out now quickly. You go to the community site, if anyone's wondering, and down here somewhere, Calcam has launched. Where are we? I saw it yesterday. Where is it? There. If you're looking for one of these, Calcium is doing them. There are a lot of funky colors. I think the initial version was only about this big, and we've got bigger ones now. So yeah, hit up Calcium. I don't know how much you're charging for it, or he's also offering like if you have a 3D printer, which if you don't have, you should get one. They're lots of fun. Mine's in there and hasn't done anything for 6 months because unfortunately my contract's been busy. But anyway, I digress. Sadly, John, yes, I'm old enough to remember nibbles. I am sadly also old enough to know MS-DOS 1 and CMOS and Gem. I come back to how far back we know. I just remember Horace goes skiing. Oh, yes. Anyway. Okay, so we're creating our slime. I'm being distracted. Thank you, John. I like the distraction. So, as we've got a concept of a slime, that's our game object. It has some textures you draw, but also some things we need to set up when you first create one. So we're going to make sure that we're going to initialize that. We could do some in the constructor, and some games do. When you create an object, you then set it up. But you'll find that if you have a separate function for doing all the initialization work, it's generally better. It also means you can reuse the code elsewhere, and you don't have to worry about calling it, have to call the constructor at a time. So in here, okay, so we're going to basically critically, we have our segments is a list now. Double checking, yeah. A rule of thumb is if you have a list of something, if you don't initialize this, you're going to get a null reference exception, meaning it will break. Generally speaking, I always do this. That means that it can never be null. But it is also okay to ensure that in the life cycle of an object, you say, right, I'm setting this, I'm going to set it stride, which I think is it's a parameter on here. And in here, so start the position, so where the slime should start on the screen, and the total pixels we've had during a second. So how far or fast is it moving? We also want the starting direction, which is wherever the default is. I'll see the default. Let's see now. That's a vector 2. So vector 2 is 0, so it's going to be moving left. And also reset the timer so we haven't moved yet, but we can start thinking of time and moving. Off he goes. Then we've got some input. Now again, this is right now where this is going to break, but we should quickly fix it because we don't have a game controller. We didn't add one, so we handle input, and this is where we're having our game logic done into our input. So we want to know what the next direction is going to be. Which is what's going from where? Next direction. Okay, we're not setting yet. So, right, okay, now this is just reacting to how we're doing input. So we have a potential next direction, and then based upon what we're pressed, then we want to know which direction it is we're going to be going. So we're either going negative unit Y, which is down, unit Y, which is up, X, well, this isn't game controller, this is input. There we go. Let's quickly change those because we're using that instead. That's not going to work, so now we just need to copy that bit. Yeah. And this is where it helps. So if my controls change, if my input changes, if I suddenly use a device, I don't need to change this code. It knows, oh right, these are the things I can do. Also, careful as well. So some might mistake, especially when you're learning, is that this is a nested if system. So in this, only one of these conditions can be true because it's true. I can only press one way or the other. If you've got a game where you could potentially press two keys, then this isn't going to help you because you can only one way or the other. So you can either do multiple ifs. This would also be a switch statement, except the case of these of individual checks. So there's nothing a core element to switch and change on, but you could do. But the direction of the order of how you check your input is always critical in your game, and it's based upon how your game mechanic works. So yes, this works for a single direction, pointing direction. I can only go one way. If you need to go multiple ways, then you need to do something different. And then so we take that, and then we're going to, and then we're simply doing a simple dot. With the dot product is basically just the opposing angle. So we're checking if the direction we're going to go what's he doing here? But we're not using the opposite direction. Okay. So okay, we're simply saying is the next direction not the inverse or the opposite of the direction that we're going. A simple way of doing. And so if it's not, so if we are not going this, if we are not trying to go the opposite way, which is what the dot product does, just like that, then yes, it's the next direction is allowed. Okay, so that's previous next direction. It's away. Okay, right. So then we want to handle the slime movement. So in this, let's see. No, I'm not simplifying it. Go away. Probably should. So when we're going to move, we're going to check where is the head now. We're going to say which way is the head going. We're then going to update the head 2. So basically, it's going to be 2, new direction. The head current position is going to be at the direction plus however many it's going to move. And then we're going to add and remove segments. Now, there's only one piece. Okay, so this is going to do the same thing at the same time. But this is a nice way of saying, add in another slime segment we're going to go to, and then remove the last one. Now, what the beauty of this is that because we've just got a list of segments, whether or not you've got 1 or you've got 15, it's the same logic, because it's add 1 to the front, take 1 away from the back. And even if you only got 1, you might think, well, I'm moving just 1. You want to think about this again, the simplicity of how you want to do these things, because this is going to work no matter how many slime segments there are. So whether it's 1 or more, it doesn't matter that you're adding 1 and then removing the same 1, because we're doing because this then works for all cases when you have so many slimes. And then we're going to do let's see. Okay, yeah. And then all we're going to do is say, right, well, if the head ends up at the same position of the body, then you've eaten yourself and collided to. So it's a nice little simple way to just loop through all the different segments and say, right, well, is this at position the same as this at position? If so, you've run into yourself. You don't need to do any complex logic. You don't need to do any box checking or has this. Again, this is a matter of simplification. Is that we already know where one piece is. We know another piece is. And if they're the same, they have collided. You might think, well, I want to do some fancy texture collision detection. We'll put a bounding box around here, and a bounding box, and then work out, is this intersecting with this? It's like, well, I don't need to know that because I know where this is. I know where that is. And if they're the same, they've collided. Again, simplicity is sometimes key. And you don't need to go overboard and trying to build a complicated system when the simple will answer the question for you. Oh, yeah, we're going to run over time because I'm just loving to talk here. Okay, and then we want to do growing. And ironically, growing is just moving without removing. So effectively, it's that we're capturing the last segment that we're at. And effectively, what we're going to do is just duplicate it. So we take whatever is the current last segment when we're moving, and we're copying it, and we're saying, right, it's going to be wherever the head is in which way. Now, again, this is where the reverse direction comes in to actually help you, because here's the head, he's going to move forward, but is he going up, down, left, right, whichever? Because obviously you can't put the tail and then have the head walk into it. That'd be done. So we're simply duplicating the head, or whatever is the last segment that's in the line, and we're saying, right, whichever is the opposite way you're going, add it to there, and then when things move along, it's actually going to appear in the same place. Again, simplicity is key. I'm adding to the end, knowing that everything's going to get shuffled on. You might think, well, that's a bit overkill. Why not just let it move and then add it to the end? But then you got to work out, is it moving? Have you died? Have you done something else? Again, keep it simple. So then we work out where it needs to be. We set it where it is. We normalize it to ensure that, we normalize it to simply make it a whole number, so that if I eat a bat halfway through moving and I want to add a segment, then just case of like, well, keep it, but it's then blocked up to the other. So everything's moved at whole numbers. Makes it simpler. Again, simplicity. And then we've got updates. So then this is the core operation for then joining some of these functions together. So while a game's updating, if you're new to it and you're working on the whole update, how the loop works, there is an earlier chapter. I think Chris said he was in getting started. No. In here. Well, I just remember I'm not linked. There we go. We've got the game loop as it runs around. So we know we've got initialize, load content, your game's starting, and then you have a constant loop of update. Are you going to exit? Draw. Are you updating? Exit, draw. Blah blah blah, and so on and so forth. So here we know slime. Whenever it's updating, we know that we need to update the animated sprite that it's on. So what we're drawing, make sure it's going off and doing what it's doing. We need to handle any input. And in fact, do we need? Yes, we have got handle input in here because it's checking on the input, which is actually this is more checking state than it's checking input, but it's still reacting to report. Naming is hard in games. We then want to keep the timer. So how much time has pressed since the last happened the last frame? Do the slimes need to move this frame, or are they still just animating staying where they are? If enough time has passed, then move in the direction you're going, and then update the movement progress based on the current game time. So yeah, it's just all the updates is really doing. Can I move? No. Can I move? No. Can I move? Yes. Go. Move. Right. Can I move? And that's all it's doing. Okay. Lots of you can go and read. You can go and read on this in case the game time and how it works. I suppose it's worth a comment note on this. Game time is not a fixed thing, which might sound odd. Simply because if you do a lot of work in one update, then that impacts the time it takes for the next update to fire. Or if you have a lot of content to draw, it needs to finish drawing before they can come back. And that can affect your frame rate. So how fast your updates go, how fast your drawing goes, affects your overall frame rate in the game. Most of the original XNA games were locked at 30 or 60. But if you did a lot, you could start to impact that performance and bring it down because it's taking more time to do what's in the update loop, more time to do the update. You might think, oh, well, I'll just use threading or something in, but no, that's a misnomer. Threading simply allows you to do more things at the same time, but it doesn't change the actual processing power or what's on the machine and how fast it can do it. All you're doing is breaking up lots of a big block into lots and little bits of work. It's still roughly going to take the same amount of time because there's only so much finite processing power. So there are lots of different tricks you can do to help make it faster or go quicker. Granted, this is less of an impact these days because most modern power, even phones like your iPhones or your Android phones, there's more power in those than there was in even my desktop back in the day. So it's becoming less of a concern, but it is always something you should keep an eye on. They'll have a little frame rate counter or something to keep an eye on to make sure you're going off, and try to offset or move things around. So you might do certain operations in one simple way. It's a case of you do some things in one update loop, do others in another. You do like a split kind of update. There's lots of other different techniques can help to move processing. Some cases, in the more advanced cases, what you'll try to do is move processing into the graphics card. The graphics cards themselves are also a computer, funky sound, but they're also better at certain things. So some games move all their physics processing into the graphics card and have it do it because graphics cards are much better at crunching numbers than your general processor is, and trade-offs. But for the beginning, for games like this, don't worry about it. For instance, the Ascent game, which is a huge 3D game, lots of things. Tom's got that running at 2,000 frames per second, and we haven't even done any performance tuning in it yet. So performance tuning is something you need to worry about when you need to worry about it, but learn the principles so you know to do things the right way in the beginning, and so on and so forth. But we move on. So take time to read through this, looking at what you do. So if I did a loop in here, go on. It's more nice. Oh, I've turned off autofill. Here is 0. I is greater than 100. It's been a while since I've manual tab on these things. Right, plus to do long thing. If you have a loop like this, which is doing something heavy and long or just waiting time, that is holding up the update in this frame. It then also impacts every single other long running thing in the framework, and that brings the slowing down. The same can be said as well if you try to do. You don't use batching or you use some kind of you're sending like 4 8K textures to the graphic card every single frame. Things that take time will slow your game down, which it sounds obvious, and it's amazing how many people it gets tripped up with it. Anyway, we then going to draw a really complicated draw because all we're really going to do is say, for every bit of slime we've got, we need to draw the animation. And also, it's a case of yes, if where slime is moving, then also when you're drawing it, draw it moving, else it's just going to pop along. That's a simple thing to actually make it smoother. So doing lerp or linear interpolation. There's also sine linear interpolation. Oh, there's loads. Loads of different ways you can get things to run smoothly. You can use a power curve, whatever else, whatever suits your game. Lerp is one of the most commonly used things in there, and most things are good. Lerping. Maybe that should be LARPing. There we go. It's LARPing. Have a good laugh. We'll dress it up. Yeah, there's notable. Yeah, like I said, lerp is just a case of like take this value over time, make it, and this is the destination value. So change it over time to this at this speed. So how much time is passing in each update? We want to go from here to there, and this amount. Okay, now obviously, while we know where the slime is and we can control things, the bat is something else. So we still need to have some way to determine has a bat also impacted with the slime. Now, the bat as it's moving, if you've watched the trailer and things, the bat is moving around the screen in all different ways. It's not like the slime where it's moving this segment, the segment, where we can just test, like I say, we can test itself as a simple test. The bat's moving around. Also, the bat can bounce off the back of the snake as well. So we need to have some simplistic level of collision detection in here. So what we need to be able to say is the slime is taking, or each slime segment is taking up this amount of space. So that, but again, keeping it simple. So we're using the circle, which is just like basically a flat 2D sphere, and saying, right, which a sphere, as we've talked about previously, is the most simple method doing collision detection because all the breaking it down into is two values, where it is and how far out it goes. And it doesn't matter where it is on that, it's just the same thing. I'm here and I'm this, my maximum bound is away. So I've got another circle, it's here, this thing. If those two overlap, it's a very, very simple calculation. And yep, so well, something going bound. So we're saying about with this position and with this wide. Note, okay, the width is half of because we're talking about a radius, not a diameter, a radius, because that's like from the center, how far out we're doing, and that's what we're checking. And that's for each slime bound. So we can then loop through each slime bound, work out, get the bounds of what it is. And you might think, well, might just draw the circle on it and then let it work out. The problem is that you need to work out where it is this frame. So in this position on this part of the screen, and it's this far out. Granted, although this isn't terribly overkill, you might notice here a simple performance optimization you can do here is just save that value, because its width in half is a fixed value. It's never going, unless it's going to, it might expand if it's animating, but realistically we're keeping it simple. So instead of doing that twice, we might cache it and say in the sprite, what's its half width? Yeah, let's do this. Let's do it. Let's stop talking about it and go and do it. So here we got a width, which is the region width times its scale, because obviously it can scale. And can't you know these are still calculated values. So I'm not saving. If we do that, I'm not saving anything unless we want to go back and change even more, because then, yeah, oh, we'll leave it alone. No, because we want to save code as well. So if I have my half width, which is, well, yeah, let's copy this here. Width is that and a half, and there. Whoa, I hate that. Come back. There we are. This also means I don't need to keep doing it all the way. I'm always for little tiny optimizations. Granted, this can be optimized even more by basically caching or storing this as a value, because the height is a stat. Height, granted, is a scale element, but only if it scales. You might want to think, does it actually scale in the system or not? But we're not aware of that. We're just trying to make our code. So now sprite is half width. So I'm not doing that, but also means I'm not doing it twice that. Oh yeah, we don't need the brackets as well now. That's right. If I want to change what this calculation is now, I need to do it once. Anyway, I digress. That's just me. Yep. So we're working out how we're going to move it in a steady way, and we're setting a simple bounding circle. You can almost argue as well, this should be something on the slide. Yeah. Again, here's me. I just can't help myself. Just make sure I'm not. No, that's not a good idea, because we are using that calculation there. Now, see, this is me going. See, again, sound like a good idea. It wasn't, because we wasn't. There is a way to do this. Well, that's not overcomplicated. So we're now handling how the slime moves. We've prevented from you being able to go back on yourself, so you can't. We detected if you're colliding with yourself, one slime segment is in another slime segment, and then added some movement, so our slime should now be moving around and growing, although it's not doing any growing because we're not told it how to grow. Well, question, I tell a lie. We've got our grow method, but obviously nothing's using it right now. We're moving, we're doing input, and we're not even initializing yet. Interesting. Okay, so again, we want to go and do the same with our bat. So let's go and add our bat class to the Batman row Robin. Okay, so we got our wheel on a bat, and a lot of the bats can be similar, but not. And this, you might want to look at saying, well, a bat, and from an object-oriented point of view, you might want to start saying, well, a bat and a slime, they're the same kind of things, and they share a lot of things. So, they both have a velocity, they both have a sprite, or they might not. Again, simplicity sometimes is key. In this case, a bat is separate and it does its own thing. It moves at its own speed independently of the slime. Yes, it shares an animated sprite, so I could share that, and I could go and create a common class which has the sprite and the two get effort. I apologize. Yes, I'm a geek. I am also a Python. You might get some British humor and lots of Python jokes in the stream. I apologize in advance. I'm a geek, I'm a nerd, and I do generally get all the points for that. Okay, so in here we need we're going to put, obviously need to know where the bat is whenever it's on the screen. And we're going to construct it and initialize it exactly the same as we did with the slime. So we're basically setting the sprite, and we're also setting our sound effect from here. But then we get some funky things. Now, we already did this in the original game code, where the bat randomly has changes its position or changes the velocity where it's going to be. But so we're just going to move it in. This will take some stuff out that was in the main game code, and we're putting it into the bat because it's code that only makes sense to the bat and not to the slime. And also another bit of code that we've got in a game class already is where we take our bat and we say, has it collided with one of the walls, so that the top, the bottom, left, and right? If it has, we're going to get a new position, we're going to give it a new direction, we're going to reflect and give it and change it to something else, and also play sound effect. This is all stuff that's in the game code already. We've gone over it. But ultimately, then, like the slime, now we're going to add in our bounds. So while the slime slime segments have got their own circle, their bounding elements, we're going to use the same for here. Okay, we can now do what we did before. Simplify, because again, so this is exact same code somewhere else doing the same thing. Get rid of that. Optimize Prime. And I'm going to horror fight. There we go. So now we've got a bounding equation to work out what space the bat takes up. We've got bounding equation to tell you what each of the slime takes up, so we know if any of those collide. If it's the body, it's not going to do anything. If it's the head, all bets are off. Bat, you're toast. Then we're going to need to update. Again, this now is just code that we had in our game code, where the slime was controlled by the input. We've changed that slightly. The bat was just something moving around the screen. So this is literally just moving code around, and the bat draw is going to be exactly the same as the bat draw we had in the game. Good here was moving stuff into the place where it needs to be, and then we can clean out what we had before. What? No, we're not doing implementation. This is just not good enough. Yes, no. Oh no, that's a heavy chapter. Okay. Oh, we've run to the end of that. But so you can see this in here now is that we're taking out code. Let's give it a view. And let's put so our bat. We've got our original game code. We can play around here. So there's our game, which again, this is not good practice, but this is the point where we're at now. If I split that and get rid of that one. So here's our game, and get rid of you, get some more screen space. So in our game, all the initialization. No, we've already ripped out all the code. Oh yes, we cleaned it up when we cleaned up before, so there's nothing in there. But one of the beauties here is that, as part of this, what we teach from the beginning here is that use source control. Source control keeps the entire history of it. So everything I've ever changed, everything I've ever changed, it remembers. So here's everything I've changed over time. So you can see that, I went and added textures, and that's what happened. In fact, let's get rid of the split. We go back over here. Let's see our game class over here. So in here we changed, we added the logo, we did some drawing. But let's see now, before we did, back to collision tile maps. Where did we do the clear? It must have been chapter 17. Yes, okay, so we go before chapter 17. So this is looking back in time on what my code looked then, and I can say, oh, well, I removed something that was important and I changed it. And what was it? What was it again? I can't remember. Source control goes back and tells me what I changed. So this is where our game class looked before we cleaned it all out. And you can see here now that we initialized the room, We set a slime position, we set a bat position. There we are. There's the assign random bat velocity, which is something we just implemented into the bat itself. Yeah, we went and loaded a load of content, and then here we are, our update. So there's our collision detection to see if the slime and the bat were colliding. We did checking on the slime, but we're removing all that. And then again, we're doing the collision detection. We again recognize this now, it's all code we had. So there's the collision detection route for our bat. It works out. There's all the collision detection for is it to work impacting the walls, which we cleaned out. And if it's not, if it hits the wall, then reflect and come back. And also then some checking to see if the slime intersects, if the bat intersects with the slime, we kill the bat. And as I realized, is that we're not. The bat exists. We just move it. Sneaky. The bat fights. The slime grows. The bat has jumped off to somewhere else. It's teleported. I got you. Well, and then yeah. So then we got the drawing code. Now let's see. Yeah, the bat drawing code. We're literally just drawing it at the position. Let's just update. And in here, yeah, we're just doing the same. This is where we were, then we're going. So let's recap over and just wrap this up for this week because we've got a lot in here. So in here now, when we actually start about our game mechanics and how we're going to do it, we're breaking things up into their own discrete things rather than just being one huge game class like we had there. Now before, all right. Yeah, before we had, this is our game. This is all of our game in one class file, which is great to throw it in and read. But now we're thinking about how our game's being built. We know we've got our bat. We know we've got our slime and how the slime is then made up of segments. And we've also then looked at refactoring input, although we had already done that, to be fair, in a previous segment. So now everything else, now all the pieces are set, the board is ready. And next week we can go into actually taking these now and start to actually then flesh out what our game looks like and our whole logic. So let's move on, he says. So as with every week and every time, so if you're on the tubes, then give us the old like and subscribe. If you're on Twitch, then hit the bell and get notified, so everything helps to grow the channel and grow the streams. And go check out the other streams if you want to learn more code and more funky stuff. So do you have any other questions we didn't look at? I think there was one I said I'll come back to. Let's see what we got here. Yeah, thanks, Michael, for talking about the content builder. I love the content builder. It makes life so much simpler and breaking things out. Thanks, Tristan, for joining in. We're drinking water. Sure, there was one question that threw in there I didn't answer. But apparently not. Oh, everyone's quiet. So in that case, we are half an hour over. Ooh. I just really liked to rabbit on in that last session. That was fun. But anyway, everyone's quiet. Okay, so thanks everyone for joining. Doing lots of MonoGaming. Next week we are taking our mechanics, our what we built, and then we're going to we're integrating and building into the game itself. So organizing the UI, organize the gameplay, put everything else in there, and then we are into a fun topic: shaders, which is a dark art itself. A job market for MonoGame engineers. There are an increasing number of engines or games being developed with MonoGame. If you look at the show, look at Showcase, or even look at Discord, and you see a lot of things there. But generally speaking, people are building things with MonoGame rather than doing one or two things. They're either learning to program, because it's having stuff fun on the screen to draw and things to play with is a great way to learn how to program, as well as how to all the different tricks, loops, updates you can do, tools you can build with it, and understand programming as a concept. But generally, you don't start really learning MonoGame to go and get a job working in a MonoGame house. It's not like Unity or Unreal, where there's huge multi-million pound studios if you get into it, generally it's either indie gaming or you're looking to build the game you want in the way you want and what you're doing. So, yeah, I mean, there are studios out there who will hire people. So, I think Stardew or Terraria, that they're always looking for people to help out and sort of build the games. But I wouldn't say get into MonoGame to learn to get a degree or to be proficient in MonoGame to go get a job in MonoGame. Although there are channels in the actual Discord about being for commercial opportunities for people who are experienced, but they're generally looking for people who are experienced. I'd say the main thing you learn MonoGame for is either to have fun and build games, or to really flex and test your skill with programming and building things out, and learn about all the language and things. It's what they're doing in universities now, where they're using MonoGame as a way to teach you C# in a fun way. And it will help you with other things, but yeah, to get a job as a MonoGamer, probably not. I'll be honest. We do it for the fun, for the prizes, or if you're joining the community on the Discord, who are the most active community I've ever come across. Everyone's building games, either in the spare time, good, or in some cases that they've given it work and they're actually building the game of their dreams in MonoGame. And you can't really go wrong, because in MonoGame you can target everything. You can target mobile, consoles, PCs, headsets, lovely devices like this. It's like this, the Asus ROG. I've got Dungeon Slime running on this, which is lots of fun. Which will show up at some point, because it all transports and just works. But that is me. Anyway, yes, modularity. I mean, not just games. Almost any development project you do, how big or small, learning how to break up code, learning how to organize things that can be reused. For instance, so Dungeon Slime now, it's got one library which is like ending code and all the game codes in the game. But personally, then I'd also say, well, the game code should have also been its own library, because I want to take that to multiple platforms and breaking it up. So the platform is almost an empty. What you'll see in a lot of our samples is that the game is just the actual project. The game project is an empty shim. There's almost nothing in there except for art assets particular to that platform, a little bit of content and things which again specific to that platform. But everything about the game is separate. Even in the 3D platform samples that we do, where we do a slightly different way, we do shared code instead of a class library. Again, that code is kept separate from the game, because the platform, the runtime, is wafer thin. You don't want anything in there, because then if you want to add another platform, so like DirectX or go to Android, all you do is creating another project, referencing your game, and it will run. Not always exactly like that, because you do need to have certain considerations. Some of your game might need to scale or adapt differently depending on what the platform is. But then you have a choice. You can either build that into your game, because it's going to be the same across Android and iOS will have a lot of shared characteristics, or if it's something very specific to a platform like Xbox or PlayStation, you'll build it just in that platform, so it does it there, but doesn't infect the rest of your game code. And then, yes, there's nothing wrong with a case of well, this is my collision library, or this is my game code for doing all my UX. Or even better, there's a huge community out there now. I've got lots of packages and things that you can include in your project, and it's just like any other class library. You get a NuGet package to MonoGame Extended. You get a bunch of extra features that you never had before that's available in your game, and it's either in your game project, which not really, or in your game library, and that's running games. And those tips and techniques are safe no matter what you're building, whether it's web, whether it's desktop, whether it's big architected platforms. Understanding how to program and how to architect your code is critical. It's just one of those things you should learn and do as a programmer. Anyway, I've rambled on enough. I've got work to do, he says. Oh yes, if you do Maui, you're already well versed in how how to break up things to make them work. And what I'd say is, what specific take 10 tips? Keep coming back to the channel, chat on Discord, or even better, just There's programming channels for chatting in the actual Discord as well. And there's tons of advice from lots of people, well-seasoned people for doing things. Yeah. Lots of funky things out there. So go out there, ask, do what they do. But anyway, I shall call this to a close. Like I said, I've got a job to do. Thank you everyone for joining. I shall see you next week for more funky and hopefully having a game we can actually show and work on and play. So I'll see you out there.